Hello everyone, I'm Paul and today we're solving problem 1498, number of subsequences that satisfy the given sum condition. This one is medium and the key here is 2 pointers, so let's see how to solve this. We are given an array of integers nums and an integer target. And our job is to return the number of non-empty subsequences in which the sum of the minimum and maximum elements is smaller or equal to the target. And we need to return this modulo 10 to the power of 9 plus 7. Now down here we have the constraint and we know that nums.length is smaller or equal to 10 to the power of 5. This means we can't do a brute force approach here. We need to think about something more efficient. So let's say we have this. This is nums and this is the target. Now let's say we remove this. This is a valid subsequence. If we remove this and this is also a valid subsequence. And if we remove this is also a valid subsequence. So we can build subsequences by removing some or none of the elements. Here we can take the following subsequences. And the sum between the minimum and the maximum element here is 6, meaning 3 plus 3 is 6. Here the sum is 9. Here the sum is 3 plus 6. Remember, we are always taking the maximum and the minimum elements. So this is 9. And here the sum is 8. Now every value here is smaller or equal to the target, which is 9. And given that we have 4 valid subsequences only in this array, we return 4. Now let's see how to solve this. The first thing to notice here is that for each subsequence we only care about one element or at most 2 elements. So if we take 3 for example, the sum of the minimum and the maximum elements is 6. And this is a valid subsequence, and here we only care about one element. Now if we take the subsequence 3, 6 and 5 for example, we only care about the minimum element and the maximum element. And 6 plus 3 is 9, so this is also valid. And here we only care about 2 elements. So the conclusion is that for each subsequence we only care about one element or 2 elements as a maximum. And this enables us to sort the array. And then every time we are observing a subarray, we know that we have the smallest element to the left and the larger element to the right. And we also know how many elements we have in between these two. Let's see what this means. Let's say we sort this, and now we know the minimum element here is 3. And if we take 3 and 7, for example, the sum is 10. So this is greater than the target, meaning we can't take 7 if we take 3. Now let's see what happens if we take 6. 6 plus 3 is 9. We know this is the maximum element and this is the minimum element. Now we are observing this subarray, and here the sum of the minimum and maximum elements is 9, and 9 equals to the target, so this is valid. Now if this is valid, for sure we can take a subsequence with 3, 6, and for sure we can take a subsequence with anything that's in between, so 3, 5, 6. And given that every element in the middle is smaller than the maximum, we can also take a subsequence with this and this, meaning 3 and 5. And of course we can take a subsequence only with this, meaning 3. So just by knowing that the pair 3 and 6 form a valid subsequence, we know that we can take these 4 subsequences. Now let's step back for a second and let's say we have a left pointer here and a right pointer here. And each time we will take the sum of the value at the left pointer and value at the right pointer, meaning the sum of the minimum and maximum values. So in this case the sum is 10. Whenever the sum is greater than the target, we update the right pointer one step to the left. Now the right pointer is here and the sum between 3 and 6 is equal to the target. So when the sum between left and right elements is smaller or equal to the target, we need to update the left pointer to the right. But before doing this, we need to add to the result the corresponding subsequences. And now the final question is, with this information, how many subsequences should we add to the result? And the answer is the following. We know that 3 plus 6 equals to 9, meaning it equals to the target. So we are about to update the left pointer one step to the right. And before doing this, we need to add every possible subsequence that starts with 3. So this 3 is a fixed value. And now we can either choose to take or not to take every subsequent value. So we can take or not take these 5. And we can take or not take these 6. So here we have 2 possibilities and here we have 2 possibilities. This means we can multiply this to get the total amount of possibilities, meaning 4. So we have 2 possibilities to the power of right minus left, meaning here we have 2 possibilities, here we have 2 possibilities, and the range right minus left is this. And let's see what this means visually. We are fixing 3, meaning here we'll start with 3, and from here we can take 5, 6, we can take 3, 6, we can also take 3, 5, and we can take 3. So these are the 4 combinations. These 4 combinations. So now we can add these 4 to the result. The result is now 4. And we can update the left pointer. Now we can forget about this 3. Now left pointer is here and the sum between 5 and 6 is 11. And 11 is greater than the target. So we need to move the right pointer one step to the left. The minimum plus the maximum elements in this case is 10, and 10 is greater than the target, which is 9. So we continue and we update right again. Now right is smaller than left, so we end this loop and we return 4. Time complexity for this will be big O of n log n. Base complexity will be big O of n, and this is basically because we need to sort this array. So now let's go with the code and hopefully you will get the idea. First we'll put our mod value up here, so mod equals 10 to the power of 9 plus 7. Now we need to sort the array, so nums.sort. Now we will set our left and right pointers, so LR equals 0 and length of nums minus 1. The result is initially 0, and finally we will return the result modded by the required value. And now here in between, while left is smaller or equal to right, if nums at right plus nums at left, meaning the minimum and maximum values in this array is greater than the target, we update right one step to the left, meaning right minus equal 1. Else we update left one step to the right, meaning left plus equal 1. But before we need to add to the result the corresponding amount of subsequences. So to get this we do 2 to the power of right minus left modded by the required value, and we use our Python function po. So this is it for the code. I think this is right. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.